Hi everyone, my name is Colin Momchada from Free Rock Investments, all things electrified. So today I'm going to do a load analysis as our first lesson for a solar system. So first, we're going to do this load analysis for a middle class house. Let's say 10 rooms. Maybe sitting on a 300 square meter stand. So first, maybe we say the appliances at that home maybe two TVs, 65 inches, subwoofers for sound, fridge, fans. Maybe the family needs some fans. Also, let's say we have other miscellaneous things that can come and be used at the house, that are going to be used at the house. So let me take you into the calculations. Okay guys, so our table here, at this first column we have appliances. These are the appliances that the house might have. So firstly we have a TV with 65-inch and a home theater and upright fridge, electric fan, the list goes on, washing machine, bowl, laptops, decoders and other miscellaneous. So now on the second column we have quantity of those appliances. So we have two TVs, as you can see. Then we have home theater 1, upright fridge 1, electric fan 1. Then lighting points, these are the lights and the security lights around the house, even on the drawers. So we have amount of 16 points. Then we have washing machine 1, laptops 2, decoder 2, and miscellaneous 1. Then we go on the power which is demanded by these appliances. This is the power demanded by these appliances. So the power is 120 for 65-inch TV. Then we have for home theater, we also have 120 for the sound. Then we have upright fridge is 180 watts, electric fan that's 65 watts, and our lights, our LED lights, as you can know today, maybe 10 watts. Then we have washing machine, it's 250. Then maybe the house is a bowl for water supply. This is 1,500. Laptops 80, and the list goes on. And then now, after this, the fourth column is total power. The total power, we get the total power by saying power times quantity. So as you can see, 120 times 2 gives us 240. 120 times 1, that's 120. 180 times 1, that's 180. 65 by 1, and if you can grab your calculator, you can do this also as the video proceeds. So let's go on the fifth column, which is the backup time. What is backup time? Backup time is the run time which the appliance will run on a day-to-day basis. What do we mean by that? Let's say a TV is on for how many hours a day? As simple as that. So the TV might run for 8 hours a day, depending on how they normally do their chores at home and whatnot. So our home theater runs for 4 hours. Then a fridge, as you know, fridges have also sometimes they have thermostats for turning off and turning on after some time. So it might run for 18 hours. And the electric fan for 1. So as the list proceeds. Now let's go on the last column. The last column we have total consumption power. What is total consumption power? This is calculated by saying the total power here, the total power on column 4 times the run time, and then we get watts hour. So which is 240 here by 8, we get 1,920 watt hours. 120 by 4, we get 480 watt hours. 180 by 18, we get 3,240 watt hours. And if you can get a calculator, You can even also proceed with the calculations here from this table. So let me take you down here. We have what is important in this table, what we call instantaneous power. Instantaneous power is the total of summation power of these totals, of the total power. Here 2785. If you add up this row up from here to here, you get 2785. What do we mean by instantaneous power? Instantaneous power, this is the power. That's when the appliances are working at the same time. The power that is needed at that time. Let's say like as per now, what appliances are plugged in, a fridge, TVs at that time. So this is the instantaneous power. So let's go now as we finish on the total of this total consumption power. So you add up all from this row up to the bottom here on 90, we get 12,495 watt hours. So we don't stop there. We then add 20% losses for system losses. These are system losses from our system, but we say 20% of this value, 12,495, which gives us a total of that value plus that 20% gives us 14,994 watt hours. So this table just gives us an overview of the total power demand that this house will demand when the appliances are now fully functional. So guys, this value, this instantaneous power value is very important, and also this total consumption power 14,994 and 2,785, because we are going to use them later on for PV solar sizing, and for inverter sizing, and for battery capacity sizing. Thank you. So guys, please share and subscribe.